Hi, my name is Devin Murray, back in the Technicum Training Center located in our North American headquarters in New York. And this is video number 2 for the PFB to look at the wiring of the conventional diagnostics. So let's take a look at how easy it is to wire up a safety system. So here's going to be a wiring example of using 3 electronic safety devices going to 2 PFBs. And because we have 2 PFBs, we can have a maximum of 8 devices, but just to keep things simple and give you an idea of how to wire this up and how to configure those dip switches, we're just going to wire 3 devices. So 1 device to 1 PFB and 2 devices to the other PFB. So what do we have here? We have an RSS36 going to the first PFB module, and then we have an RSS16 and a locking device, the AZM200. Remember from the first video, you can mix and match lock-in and non-locking devices to 1 PFB. Looking at the wiring, so we have the RSS36 with an M12 connector. We offer the double-ended cables, and we offer longer lengths than this, of course. So we have different options for those cable lengths. So a M12 connector, double-ended cable going to an M12 connection on the PFB. Same thing for the RSS16 and the AZM200. All of our safety electronic devices have a means to connect to the PFB module. So you have your connection, your double-ended cable. The last double-ended cable will be from the first PFB module, so that M12 4-pole. And you see that long cable, and go into the next PFB module. Okay, so far everything is nice and simple, plug and play, double-ended cables. The only flying lead cable connections that we will need will be for this first PFB module and that 4-pole cable. Okay, for the power will be for our safe outputs as well as our power to the system. Okay, so 2 safety outputs and then a 24 and a 0-volt pin. The other connections that we have will be for the diagnostics of the devices. So if we zoom in here, we see this connector, the I/O connector, will be for the diagnostics for each individual device, as well as the locking signal for the locking device. So it will be a 8-pole cable, 1 pin for the diagnostics, 1 pin for the locking. So 2 pins per device, and you could have up to 4 devices, which is why we have 8 pins. We have a locking device, so I will connect the I/O cable so we can provide that lock and unlock signal to the AZM200. To keep things simple here, we don't have a locking device, so I'm not going to wire the I/O cable for PFB number 1. But again, you will see it with PFB number 2. Here we have a representation of a control panel. So we are going to send our safe signals to the SRB301ST. And if you're not familiar with the SRB E-Series, I highly recommend you looking at the video here on our YouTube channel. They are an awesome series of our safety controllers. Again, keeping things simple, I will program the SRB E301ST to monitor for an automatic reset and without a feedback loop. Which means as soon as the guard doors are closed and there are no faults on the devices, the machine will turn on, which is simulated by this machine dome light here. So what I'll do is I'll pause, I'll go ahead and wire this up and then bring it back on to show you what we have. The one thing that I do want to show with the wiring is the dip switch configuration. So this is the first PFB, and we are wiring just 1 device. So what we'll do is we'll turn on dip switches 1 and 2. And for the second PFB, we are wiring 2 devices. So we'll turn on 3 and 4. And because this is the last PFB, or the PFB furthest from the safety controller, right, that's the cable going to the safety controller, we also have to turn on dip switches 7 and 8. All right, and of course we have those covers. Remember, from radio number 1, we can tighten those down and call that portion of it complete. So again, I'll go ahead and wire this up, and I'll show you what we have. So we are all wired up here. We have our 3 safety sensors going to our 2 PFBs. We have on our SRBE monitoring device, we have N1 and N2 illuminated, which means that our safety outputs for our safety system are enabled, and we have our out LED illuminated, which means that we have safety enabled. We have our 2 contactors, and we have our machine light, so the machine is running. If we were to open up the guard door, you hear that clicking. That's the contactors dropping out. All right, guard door closed. They are triggered, the machine's running. Okay, so open, close. If we look at the LEDs on the PFB, now the internal wiring between the X and the Y outputs of the electronic sensors will show the enable of the next unused connector being illuminated. So we only have one device here, but the next unused connection will have that eye illuminated. But if we open up this door, okay, that connection that we have there, that safety enabled LED drops out. And we go ahead and close it back. On the second PFB, here we have the locking device, that AZM 200. Well, if we go ahead and send that unlock signal, you hear 2 clicks. 1 click is the contactors. That other click you hear is the unlocking of the AZM 200 solenoid. So we have a flashing light, means that it's unlocked. Solid light means that it is locked. Okay, looking at the LEDs on the PFB, the AZM 200 is the second sensor. So because it's the sensor upstream, when those safety outputs drop out, they also drop out the safety inputs for the RSS16, which is downstream. Because of that, those outputs drop out as well, which is why you see the LEDs for both sensors dropping out. However, if we just open up the guard door for the RSS16, which is the last one downstream, you see that only those safety enabled LEDs drop out, not the one for the AZM 200. But because we are wired in series, even though those safety outputs are enabled, we have a guard door open. So the machine is not running. So we still lose our safety outputs. Okay, and on that PFB, we have some unused connectors. So we have the end caps on there, we have the caps on the dip switches. And again, just like the first PFB, on that first unused connector, you will see the P and the I LEDs illuminated, and that's because of the internal loops between the X and the Y outputs. If you have any questions on the wiring of the safety devices, what those X and Y outputs are, give us a call. Look at those YouTube videos, but definitely give us a call, and we can walk you through the wiring. But that is the PFB. Okay, so again, those plug-and-play connections with those flying leads. One flying lead cable will be for the solenoid controls and the diagnostic outputs for our devices. And that second flying lead cable will be the power cable for our entire system, as well as the safety outputs to our monitoring device. And I thank you for taking the time to view this video. If you have any questions at all regarding the PFB or applications regarding the PFB, please give us a call or shoot us an email. Thank you and have a safe day.